hold it down here.
By one. Okay. Yeah, I tried to make it not too long.
Okay.
All right.
Okay, everyone. I'd like to welcome you to another transportation seminar. We hold this every week, and my name is John Glebe. I'm an assistant professor in the School of Urban and Regional Planning. I host this along with my colleagues Jennifer Dill, Miguel Figliozzi from Civil Engineering. And today we have Jenny Liu. Jenny is a visiting assistant professor in the Department of Economics. She got her PhD probably a little over a year ago.
Last year.
Last year. From University of California, Berkeley, in the Department of Agriculture and Resource Economics. And she conducts a lot of research in transportation, energy, and the environment. What she's going to talk to you about today is one aspect of her research on transportation, and it looks like household vehicle choice adoption. And before we hand the presentation over to Jenny, I'd like to remind you that we will be taking questions at some point, either at the end or whatever she decides. But whenever you ask a question, please be sure to use the microphones on the desk and press them, make sure they work. And if the red light doesn't light up, it means it doesn't work, in which case I will try to come around and give you the handheld mic. Okay, so without further ado, I'll turn it over to Jenny.
All right, thank you. My name is Jenny Liu. I am currently visiting assistant professor over at economics. So today, what I'm really going to talk about is how we do vehicle choice modeling in the world of economics, because I noticed a lot of the talks that were given here are mostly engineering, urban planning, that type of topic. So I wanted to do an excerpt from part of my dissertation work and also give you guys a little bit of a background of what has been done in the past in the realm of vehicle choice and economics. So you can ask me any clarifying questions along the way, but if you have any really big picture types of questions, I would prefer that you hold it towards the end so that we can sort of get through the material first before explaining all those concerns that you guys might have. Okay, sounds good? All right, so some of the motivation for this, it's pretty obvious probably to everyone here that transportation is obviously a very important thing and a very important aspect of life in an urban, particularly urban setting. So part of the motivation behind this is that we really wanted to look at vehicle choice and ownership and how do people use this from an economic perspective. And there are a lot of applications to this. Let me list everything up here. So there are a lot of applications. One of the major fields of research in economics that have to do with vehicle choice comes from just forecasting vehicle sales that have more to do with the marketing side of things, just letting the corporations and companies know how to sell what types of articles and how, what types of cars and that type of thing. And again, it's also very related to policy planning and using economic modeling. We can try to forecast and predict what can happen if we were to provide certain types of policy incentives for example, hybrid cars, electric cars. How much is it going to affect people's choices? Or it can affect, or taxing is another topic. For example, gasoline taxes. How much does that affect vehicle choice and usage? And then also public transportation is another big topic. If we were to be able to figure out, determine how people choose their mode of travel, then we would be able to find out how to shape our public transportation policy and funding and that type of thing. And then finally, environmental issues is another big area of concern because, as you know, vehicles usually have all sorts of emissions into our environment, and how much they use the cars, essentially. How much do they travel relates directly to how much they are using of gas, and that directly translates to how much emissions they have, depending on what type of car they have. So these were some of the types of things we were thinking about when this research got started. So just taking a look at some US vehicle sales data was part of our motivation behind this. So this is a very short span of time, maybe 10 years. We're looking at American-produced cars, foreign-produced cars, and then also the total new vehicle sales. So the American-produced cars, mainly the big three companies, Chrysler, GM, and Ford, their vehicle sales have been dropping very significantly. So this has an economic impact on our US economy. So that was one of the reasons we wanted to look at this. And foreign sales obviously have been increasing over the years. And this is very significant, especially if you looked at the overall vehicle sales. So the overall vehicle sales remained pretty constant throughout the early 2000s. But as our economy went through a downturn, vehicle sales dropped very dramatically. But in addition to that, foreign car sales remained very strong in light of that happening. So, so we wanted to see what caused that type of phenomenon. And at the beginning of conducting this research, we sort of code-named our paper "The Death of Detroit," but then we thought it wouldn't be very politically correct to put that in my dissertation. Yes?
What is the scale, vertical scale for the three graphs?
So the first two, the American and the foreign car sales, those are percentages of total car sales. So what percentage of all car sales, for example, in 1998 were American-produced cars, around 70%, and 30% foreign cars. And then the gray line that shows the total vehicle sales, that's the in millions.
Thank you.
Okay. So, so we wanted to figure out what was going on, basically. And we also wanted to expand and also look at the world. And we looked at some just very preliminary passenger car sales data to see what was happening in some of the developing world, because we think that if we were able to develop a very strong model of vehicle choice economics, we could potentially apply it to a lot of developing countries where we are very concerned about the environmental outcome of vehicle choice. So in the US, this is what it looks like. It's pretty much the previous graph. In China, on the other hand, from year 2003 to 2008, you can see very, very strong increases in passenger vehicle sales. It goes to close to 7 million passenger vehicle sales at the end of 2008, which is more than 3 times of how many were sold in 2002. So that's very significant, as that kind of growth is something that we want to look at. Finally, India, there's some growth in their passenger vehicle sales, but not too significant, in part because their infrastructure is not very complete, and they mainly go with two-wheel transportation modes like scooters or bikes, that type of thing. So their vehicle sales was pretty flat. But overall, we wanted to look at the US first, and then we want to be able to apply that model to developing worlds and maybe other developed worlds like in Europe or Japan, that type of thing. So, okay. So I wanted to briefly talk about why is vehicle choice different from other types of consumer goods. Really, economics is all about looking at consumer behavior, who buys this, who buys that, who buys how much of it. And vehicle choice is not exactly the same as most other things that you're purchasing. It's not the same as, for example, food that you're purchasing for consumption. It's not the same as clothing that you're purchasing in a lot of different ways. So In economics, we usually say consumers derive utility or some kind of value, happiness from consuming any type of thing. But for vehicle choice, there are some studies or some people that have said that consumers do not derive utility directly from the purchased goods. It's not that you've bought something that makes you happy or have value, but it's that these goods actually have some kind of characteristic or it provides some kind of commodity to you that makes you gain that utility. So for example, if you were to buy a new shirt, you're not gaining utility from owning that shirt, but more or less you're gaining utility from, for example, wearing that shirt. Okay, so it gives you some clothing. And you might also gain some type of utility from the shirt being fashionable, for example. So fashionable or the quality of the shirt might give you some type of utility. So this was the starting point of how we wanted to look at vehicle choice. So two people that really developed a lot of consumer choice, they had differing viewpoints of how we should characterize goods. So Lancaster, he says that one activity or one process or one good can provide many different commodities or different types of utility, much like the example that I just gave of clothing. And Becker, who is the other person who is really studies household choice of many goods, he's of the thought that one activity provides just one type of commodity to you or one type of value. But we wanted to synthesize that in vehicle choice and say that for vehicles, it's different because there are several different types of activities that you can engage in that can generate the same commodity. So what I mean is that you can choose a big truck, you can choose a small car, you can choose a hybrid car, you can choose to walk, you can choose to bike, you can choose to take the MAX, and all of those will generate the same kind of commodity, which is transportation, getting you from point A to point B. So that was one of the main foundations for how we wanted to construct our vehicle choice model. So another thing is that there is something we call a putty clay characteristic. So this is related to the literature in consuming durable goods. Okay, so think of an example much like buying a washing machine. So before you buy that washing machine, which is a durable good, which means you buy it and you can use it for a long period of time. Before you buy it, you're in the putty stage of things, which means that everything is very moldable. So you can either do all your laundry by hand, you can spend lots of time on that, or you can substitute towards going to the laundromat and pay some money and not have to do it by hand. So all of your production choices of how you achieve your the goal that you want to achieve, you can switch. So in that stage, you're like putty. So vehicle choice is very much the same. Before you actually make a big purchase like a car, you can switch between, for example, biking or getting a zip car or taking the MAX. But after you actually engage in the choice of a vehicle, you're in the clay stage. So after you purchase a vehicle, you're sort of stuck in that stage. So like clay, very rigid. You have less of a substitutability between the car and other modes of travel because you've spent a large fixed cost on that good. So that really applies to all kinds of durables and also vehicles. So that's why it's different than usual consumption goods. So we wanted to view vehicle choice as a type of technology adoption. So that's what I mean by adoption in my title of this talk. So when you're buying a vehicle, you're sort of adopting a certain type of technology. So it's like when you are buying a washing machine, you're adopting that particular type of technology. It could be an older version of the technology, like a top-loading washing machine, or it can be a high-efficiency one, which is slightly more expensive, but less cost in terms of electricity or water. So that's pretty much how we wanted to view vehicle choice. Okay, so some of our objectives in going through the study were, first, we want to figure out how do people choose their cars. Okay, so on a disaggregate level is what we call adoption, technology adoption. Disaggregate level means that we are looking at households or individual people. So on an individual, smaller scale, how do they choose to buy this car versus the other car or no car at all, for example. And then another more important policy-wise, another important part is to look at the aggregate level, or what we call technology diffusion. So that's sort of zooming out of the whole picture and looking at the population and saying, what's the percentage of people that are going with the adoption of a truck or an SUV or an electric vehicle? So diffusion is to see how far has the technology, certain types of technology, how far has it spread through the population. So we wanted to look at both of those from an economic standpoint. And then after these users or consumers make their choice of the vehicles, how does that choice affect their fuel consumption, or how much do they travel, given that they've purchased certain types of vehicles? So that's the main idea behind all of this. And then we wanted to look at some of what other people have done to make sure that we were doing the right thing and on the right track. So I wanted to show you guys some of the past research in both just vehicle choice and also the realm of technology adoption. So in vehicle choice, there's a lot of work done on the disaggregate level. So let me show all of this. So there are some models that look at vehicle holding, so basically taking a picture at the current population, looking at what are the types of vehicles people hold, and then using econometrics, regressions to figure out how are people's demographics or characteristics related to what type of vehicle they have. And then there are vehicle transaction models, which is the kind that we are going to go with, which means that when you do decide to transact and buy a vehicle, what do you choose? Okay? So Mannering and Winston, they basically did a lot of work on doing these very complicated regressions, nested logits and multinomial logits. So basically a lot of econometrics, a lot of math to try to figure out what are the characteristics that lead to certain vehicle choices. And then later, Train and Hensher came up with the idea that there's something called an indirect utility function. So what that means is that given that you have certain range of choices of all the different cars that you might have, you will optimize your choice by simultaneously deciding for each of the cars that you can choose, how much would you utilize it, and then maximizing your utility by choosing the one option that is best for your activities. So we're going to follow some of that, but a lot of this literature has many limitations. So one of the first is a reliance on revealed preference data, so basically sales data of who buys what, that type of thing. It's very data heavy, meaning that you need a lot of very, very detailed data of each household, what they're buying, all their characteristics. And that is usually a more costly way to get at this problem. So that's one of the limitations. Otherwise, there were some studies that use stated preference data or surveys. And as usual, surveys have all the same downfalls that you usually see in surveys, that you see all kinds of biases. So our study is going to try to avoid these types of downfalls by using very, very simple data in order to model on a large scale what types of vehicles are going to be adopted. And it's not going to need a lot of data. We've tried to be as parsimonious as possible and still get the results that we needed. So that's what has been done already. So on the side of technology adoption, that is on a more aggregate level here. So we're talking about the diffusion of technology. How much do people overall have they adopted? So it's very commonly believed that for any type of technology you're talking about, we are faced with this blue line, which is what we call an S-shaped diffusion curve. And this was pioneered by Rogers and Griliches. And it's pretty standard in most of technology literature that this type of shape appears. So what that means is that in the beginning of any type of technology, it could be something like Facebook, it could be like cell phones or washing machines or DVD machines. In the beginning, we have early adoption. So those are these people that are concentrated in this part of the distribution. So those are the innovators and early adopters. Those are the people that are very susceptible to new technology. They're very open to it, and they use it. So in the beginning, you can see that the cumulative percentage of how many people are using this technology, it starts out very low, and it's increasing at a slower rate. And then as the technology becomes a little bit more mature, more people are using it, then we have what we call the takeoff period, and that's the middle portion of that S-curve, which is very steep. So that's where your early majority and your late majority, the majority of the people who are more or less more risk averse, they come in and participate and they start adopting the technology. So that's a very good period for all the people that are selling the new technology. And then finally, we have more or less saturation. So we reached that top part of that S-curve where most people who will adopt have already adopted the technology. There's not much more you can do to promote that technology, except maybe some people exchanging their old version of something for a newer version. And then there may be decline after that top of the S-curve if there's a newer technology that comes about and that innovators and early adopters, again, jump onto. So that's the general cycle of things. But there are a lot of different viewpoints on how that S-curve comes about, what's the mechanism that causes people to have, or the overall population to have this shape of adoption of any kind of technology. So there are two main schools of thought on that, and I'm going to introduce both of them. But my study mainly, I believe in the second one. So, but for, in the interest of fairness and presenting full information, you're going to hear about both of them. Okay, so there's two different models of why that S-curve comes about. So one of them is called an imitation model or epidemic model, and then the one that I more believe in is the threshold model. Okay, so the imitation model has this story. Okay, so let's just pick an example, for example, Facebook. What it says is that it's sort of like an epidemic. So in the beginning, some of the people in the population, a small portion of the people are what we call innovators. So these people jump on the ship and they start using Facebook. And these people are very evenly spread out through the population. So every 10 people, there's one person that's using Facebook, and they're evenly spread out through the population of a lot of people. And then later, everyone else is an imitator. So those imitators are sort of, it's a story of contagion. So that one person who is an early adopter tells everyone around them about this really cool technology where you can network and find your friends. And then those people around them sort of catch the bug, like a contagious disease. So those people around them get that bug, and then those imitators follow the innovators, and more people become adopters of that particular technology. So this particular model really stresses the role of communication, and note that the name of the model is also called an epidemic model, which is a model of contagion, so like spreading of flu. And it is convincing in a lot of ways because you do hear about new things from your friends and then you try it out. But in the study, it's also called the BAS model. There are some limitations in that most of the studies in this school, they assume a homogeneity amongst all people, meaning that they assume most people are the same, aside from the fact that some are innovators and some are imitators. They don't account for other differences in people and households. And there's also a lack of theoretical linkages to what we believe to be the mechanism of consumer choice in economics. And there's also other downfalls, like assuming that these innovators are very evenly spread through the population, which may not actually be true. You may have people who are groups of people who are really technology geeks and they all band together, or people who like transportation usually band together. So, so you don't have these innovators that are spread out evenly through the population. So that is one of the major downfalls of that model and why we choose to use another one, which is called the threshold model. So this threshold model was mainly developed in the beginning when we were looking at technology adoption of things in agriculture. So like irrigation. Irrigation is one of the main things that they started to look at when they looked at the threshold model. And what it does is that it has a theoretical basis. So if you take in any kind of economics, there is a very commonly believed theory of how consumers choose goods, how their consumer behavior comes about. And it comes from optimizing their utility, given their budget, that type of thing. So this model is very based on that. And it can be applied to either people or firms, and it fits with the economics literature. And one of the main really good things about this model is that it actually accounts for different sources of heterogeneity, meaning that it accounts for people are different. People are, so in terms of vehicle choice, people are at different stages in their lives. It accounts for people who have different household sizes, different income levels, that type of thing. And how this model believes that this S-shaped diffusion curve comes about is that it comes about through something we call dynamic processes. So that's just lingo for saying that as time goes on, there are some things that change so that more people adopt. And what are those types of things? One of them could be what we call learning by doing, which means that in the beginning, hybrid cars may be very expensive to manufacture. So they're very expensive to buy. So that's why in the beginning you have a very slow adoption because people don't want to buy something very expensive. But as time goes on and there's learning by doing going on in the manufacturing and the production of hybrid cars becomes more mature, then it becomes cheaper because they're more mass producing, they've studied it a great deal. And then that's when the car becomes cheaper, and then we have this takeoff period of the diffusion curve. So that's one of the mechanisms that we think contributes to that S-shaped curve. And it could be other types of things. It could also be something called Bayesian learning. So it could be that people see their friends who are early adopters buy a hybrid car, and then they update their own information in the next period. So you see your friend have that car, and you see how it works. You see whether or not they have to take it into the shop a lot of times. Do they stall on the street? Does it really save them money? That type of thing. So you update your own information based on what you see in other people. So that's also one of the possible ways we get this technology diffusion. So, so how we find why it's called the threshold model is to say that if there were different types of heterogeneity in the population, so for example, one of the biggest types of heterogeneity we think is income levels. Okay? Obviously, if you don't have income, you're not going to buy a really big, expensive car. So if that is true, then you have a distribution of all the income levels. If that's the one source of heterogeneity, then you can find a critical threshold where a critical income level where people switch from one type of technology to another type of technology. Of course, that's a simplistic view because there are other sources of heterogeneity. So you could have a multi-dimensional threshold saying that if your income is above $50,000 and your household size is less than 3 people, and all of these different things that can cause heterogeneity in a household or an individual, you can find what are the thresholds of adoption. And that's the approach that we chose to take. Okay, so I wanted to walk you guys through a little bit of the model. It's theoretical, and I've eliminated all of the math from all of these slides, so hopefully it won't be very painful to get through. Okay, so our theoretical model approach is, on a very basic level, we want to look at on an individual disaggregate level, who adopts what. So this is a very simple indirect utility function. So basically, you're optimizing what car to choose given all of the characteristics you have, and you maximize, choose the best one for your situation. And then on the aggregate level of diffusion, we base that on the adoption, and then we look at the overall distribution of, for example, income or household sizes or varying degrees of environmental awareness in the population, and we find out exactly what percentage of the population goes with one vehicle type versus another. So here are some of the ones that we considered in our model. There are obviously many other ones, but these are the ones that we feel are the most essential in including. So the first one, household income levels. That's pretty obvious. Income levels contribute a lot. Household structure, that means, is it a household with children? Is it a household with single people? Is it a household with senior residents? That type of thing. And then we have a comfort quality level of the type of car. So if you were a family with children, the comfort level of a two-seater to you would be essentially 0 or close to 0 because you can't take your family in it. So we wanted to have varying levels of comfort, or what we call quality, for each household for different types of cars. And then after we accounted for all of that and tried to simulate this in a computer model, we found that not all of the ups and downs of how the percentages of adoption of different types of cars, it wasn't all accounted for. And we tried several different things, and we came up with, finally, something called an environmental awareness factor that may induce people to buy a car. And I'll explain that in a second. So environmental awareness, we thought would be something like if you buy a Prius. Prius is something that looks very unique, and you can sort of spot it right off on the street. And if you buy this type of car, you get some utility from the fact that it is a hybrid car, and you can show that you are environmentally conscious. So that was the thought process of that. But there are many ways to account for that and to look at how that's different throughout the years and the behavior behind it. OK, so this part is just what I said. Just the household utility is given by two things, one of which is how many miles you're traveling, and then a composite good, just everything else. And so basically, when you're choosing a car, you're jointly maximizing two things. So this is a discrete continuous choice. So you're choosing from one of the cars out of all the different types that are available to you, but you're also choosing, if I buy that car, how many miles would I travel on it? Because you have a different fixed cost for each type of car. You also have a different variable cost for each type of car, because every car has a different level of efficiency associated with it. And this could also include other types of transportation. So it can also account for public transportation, where you have essentially 0 fixed cost, but possibly higher variable cost. But in the calibration stage, we are doing it on a nationwide basis, so it's kind of hard to have a measure for the overall public transportation scenario, so we left it out for this part. And of course, you're subject to how much money you have, and that's the constraint here. OK, so just briefly illustrating an indirect utility here. So V1 is the indirect utility of buying vehicle type 1. OK, and here you have all income levels. So if I'm very poor and I buy this vehicle 1, depending on how much I choose to travel on it, I have this level of utility. And as you become richer, you can spend more and travel more, so you have a higher utility. So you have one of these lines for every type of vehicle that you have. Of course, these are not necessarily straight lines or anything. It's just a very stylistic illustration of this. So you can, let's say, have 3 types of vehicles. So if you were someone at this income level, and income is the only heterogeneity in this very simple example. If you were here, you could choose vehicle 2 or vehicle 1, but not vehicle 3, because that one would be too expensive for your income. So given that you have these 2 choices, you can see that for this person, vehicle 1 is the more better solution to their needs. Okay, so this, if you have this type of graph, then you can say that these two are the critical income levels at which you switch from technology 1 to technology 2, and then from 2 to 3. Okay. And there's this yellow line, which is what we call a utility frontier. Okay, so that's the main portion of the theoretical disaggregate portion about household choice. And then on the aggregate scale, we aggregated everything over the entire population, and there are several different effects. And again, this is probably, to me, it's probably easier understood if you saw the equations, but there are these different things. So first of all is a population effect. So basically, if you have more people overall, that would mean more people would fall into each of those threshold bins. And then you could have an income distribution effect, which means that the shape of the income distribution in the population could shift from one period to another. So for example, that's probably more relevant and obvious in developing countries like China, where income distribution is very quickly shifting. Then you have different amounts of people in the different types. And then these two variable costs is basically how much does it cost you to operate the car. And one of the main costs for that is your gas costs. So how much that moves around, and also how much your fixed cost, or how much you have to pay to get that car. If those things are different, then that's going to affect the threshold of where we think the critical, where people switch from one technology to another, and also affect how many people fall into each of those thresholds. Okay. So that's the theoretical portion of this. And then what we did was we took this economic theoretical model, and we wanted to build a simulation model and calibrate it to see if we use this model as our foundation, can we construct a computer model that can accurately predict, using very little data, what's the percentage of people buying SUVs versus hybrids in the US. So that's what we did. And so just before, this is the vehicle sales data trend for 2002 to 2003 when we did the actual calibration of our model. So compact cars, pretty much constant over time. There's some fall in new mid to full-size vehicles. SUVs, there's sort of an upward trend. This isn't a very long time period, but at that time, this was the only data that I could get. And hybrid cars, very low, but still increasing at a good rate since it's going from near zero in the beginning. And this is all at the same time. You have gas prices that were increasing very dramatically from 2002 to 2007, but these are nominal gas prices. So, so we want to see if we can actually have our model match these numbers. So we calibrated this model using MATLAB, and used all of these data. And note that these are all very aggregate types of data. So we looked at the vehicle sales data, and we also looked at their vehicle characteristics. We broke it down into very simple groups of different types of cars. That is not very comprehensive, but we thought that if we can get some idea of how this works, maybe we can break it down into more detail later. So we looked at how much their fixed cost is, what is their variable cost depending on their fuel efficiency, as well as the going gas prices during that year. And also some comfort quality parameters that SB and Nair, they estimated and had a metric to measure whether or not there's enough space, if the safety, reliance, that type of thing, to make it a number that we can look at. And then we collected some household characteristics on the US population, how the income is distributed, and what are the different types of households. And again, that's broken down into very big groups, 3 different types. And with this very, very little data, we were able to get pretty good results. But one thing that we could not match was the fact that the gas prices, well, we could not match all the ups and downs with the simulation calibration. So we thought that we would include one more thing, which was environmental awareness. And obviously, this is something that has to do with people's values. It has to do with what time of the year you're talking about. So there's many ways to incorporate this. So we tried a lot of different ways. Here are 3 of the ones that we tried. So we tried it without environmental awareness, wasn't very close. We tried it as a function of gas prices, saying that if gas prices are higher, then maybe you get more utility from getting a hybrid car. And then we used some revealed or stated preference data on environmental awareness. And we finally found that this was the type of thing that actually modeled people's taste towards environmental awareness much better. So these are the results. So the darker lines were what you just saw in terms of what are the actual vehicle sales. And the lighter lines here are what we forecasted with our simulation model. And it's pretty close. The one that's least accurate is probably this for hybrid cars, but it does reflect some of the trends of where we're going in terms of overall diffusion. And we also matched it together to see that it actually fits pretty closely with the data with an R-squared of almost 96%. So we were able to match the data pretty well. And then, let's see, time. OK. So, so we thought that this was pretty close, so we could use this model to forecast certain things. And we tried to forecast what would happen if we had energy price fluctuations, what would happen if vehicle prices went down for hybrid cars, different policy changes like tax incentives that brought the overall fixed cost down, or changes in gasoline prices, shifts in income distribution, the shape of the income distribution. So income distribution, the first one, the income distribution shifts are more like, are people overall getting richer as time goes on? And then the shape of income distribution changes has more to do with whether or not maybe we have more inequality, so more people concentrated at the 2 ends of the income distribution. And we came up with all kinds of different scenarios to forecast this, but obviously this was from a 150-page dissertation, so you won't see any of it aside from this one graph. So this one was, we tried to see, OK, if gas prices just went up consistently 10% every single period, the period that we define here, it could be a year, it could be shorter or longer periods of time. So if that was true, then we would have more adoption of hybrids, that's the red line there, a little bit more adoption of hybrids, but we would actually see more people buying SUVs, which is a very, very surprising result here. And that reason is because of the last line that you see here, which is the total miles traveled. So as gas becomes very, very expensive, you tend to substitute towards other goods and travel less. So you're going to be combining your trips. You're going to maybe just not travel using your car. So that effect is reflected here. The fact that the travel goes down so dramatically, that accounts for the fact that more people are buying SUVs because you gain more of a marginal utility from comfort in those types of cars. So, so that's one of the surprising results from here. Let's see. So I'm going to skip this slide, which is more detailed in terms of the results, but to show something else here. So the main determinants we found, the ones that really shifted people towards one technology versus another, was the fixed cost of technology, which isn't all that surprising. That's to say that car prices really influence people's choices. But we saw that in our theoretical and our simulation model. And it could be something that can be influenced by learning by doing, just getting a more mature technology in hybrids or electric vehicles. It could be influenced by policy incentives. And then the other really big thing that affected how many people chose each technology were income distribution shifts and the shape changes. So if people were suddenly getting much richer than before, then we see a very large move of people adopting different types of technology. But other determinants are also important. So gas prices are important, but that depends on whether you're talking about the short term versus the long term. So that's, that effect is much smaller. And changes in environmental awareness is also one determinant, but definitely not as significant. OK, so I still have some more things that I can talk about, but in the interest of time, I wanted to give you guys a chance to ask some questions. And of course, this study is sort of still ongoing. We're still planning to do more calibrations and more simulations that have to do with smaller local areas where we can get more precise data on the local characteristics, as well as doing it for developing countries where the scenario is very interesting because things are moving so fast compared to where we are right now. So wanted to skip to the last page where I show some conclusions. Okay, so concluding remarks, what I already did is there's a theoretical model on the aggregate and disaggregate side, and then there's a calibrated simulation model. And then we did a whole bunch of case studies that have to do with, for example, emerging economies, China, India, Europe, Japan, more aging economies. We also did some things that have to do with public transportation. And there are still some more things that we would like to do. So for example, as I said, calibrated for developing economies. So how do we model the transition from foot traffic to two-wheeled traffic that is maybe motorized or non-motorized, and how does that switch over into the adoption of four-wheeled vehicles? And then more randomness, or accounting for more of the differences in the individual side on their preferences for comfort or environmental awareness. And maybe a little bit of a look at the allocation of the decision power within the household, because households aren't individuals, so there's a little bit more intricacy there. And then also possibly adding the interaction of household residential choice, that interaction with transportation choice. So that is it. So I would be happy to take any questions if you have any.
Any questions?
Yeah.
Can you talk about your model techniques and your data a little bit? Like, what kinds of model you used to do the simulation and estimation? Is a time series regression model, cross-section regression?
It's not exactly a regression model in that we don't exactly use a regression. We take information from regressions that other people have done to inform us about which variables may be important. And then what we do is we use an optimization model using the data and saying that this household has these characteristics, what would they do? So
so the model results you showed us is from your aggregate model, right?
Which one?
The simulation you did.
The simulation is based on the disaggregate side, so we have representative households with all of these different characteristics that have to do with their household, for example, their income, their household size, that type of thing. And then we model their decision, and then we take that and combine that with the aggregate side of things where we figure out what's the distribution of income in that population. Does that make sense?
What's the geographic scale?
That's just for overall U.S.
Overall U.S.
Yeah, so it's not very small, but one of the main goals was to be very parsimonious in that we don't need to get expensive data in order to forecast these numbers.
In 2008, we experienced a rapid increase of gas price, and then the gas price went down. So can you go back to slides a little bit?
Which one are you referring to?
The simulation results. No.
This one, or
No. After this
one.
After this one. Later.
So
yeah, this one.
like this.
So this one, it seems you show that when the energy price increased by 10%, the average miles traveled decreased a lot. Is that consistent with the data we observed in 2008?
This simulation is a transaction model, so it only models those people who in those periods are purchasing a new vehicle. So we're not saying that this is a trend for the overall population or people who've already purchased their cars. We're looking at the behavior of only the people who are transacting at the periods that we're looking at.
Okay.
So
it seems it's the decrease of vehicle miles traveled is much more than the average number.
Because this only accounts for the small percentage of people who are buying a new vehicle, and then there's a large portion of the population who already held the vehicle that they purchased previously, and that accounts for what the data shows as the vehicle miles traveled average that you're talking about in 2008.
Okay. Thank you.
Yeah.
Thank you. So it shows here energy prices with a 10% increase per time period. Did you model different percentages as well? Did that produce radically different results? Or what made you go with the 10%?
10% is just one of the many ones that we did, and it's one of the ones where we actually see a significant increase in SUV purchases. So for smaller percentages of increases in energy prices over time, we saw that SUV purchases actually went down, or it remained pretty much constant. So I wanted to show this one to show sort of an unexpected result of the simulations. Yeah. Yes?
Talked about the environmental awareness quite a bit. Did you notice a difference between the different cultures? So, like when you modeled the U.S. And modeled Europe, was there a difference?
We didn't. Actually, for environmental awareness, we didn't use that for the other countries because that data was relatively harder to obtain for a consistent period of time to get the same measure of that across a very long period that we can calibrate. So there are differences, definitely, but it wasn't part of this particular study.
One more thing. Did you deal with the fuel consumption only, or did you deal with the CO2 emissions as well?
We did not specifically look at the CO2 emissions, but we're thinking that it's not exact one-for-one translation, but the more fuel you're consuming, it obviously leads to more CO2, but we don't account for that specifically. On this slide, yes. I did.
Clay characteristic, is that attributable to anyone?
There's a lot of people that did work on that, and right now I can't remember the specific name, but I'm pretty sure you can look it up in a lot of durable goods type of literature, but I can't give you that specific name. So, yes.
So in the beginning, you talked about one of your motivations for doing these kinds of studies is to look at policy implications later on down the line. And so going back to the environmental awareness piece of your modeling, and given that, although you mentioned you didn't see it being a huge explaining factor in all of this, but that it definitely played a role. So in terms of policy implications, what does that mean as far as like ramping up environmental awareness campaigns? It seems like that's something that's been ongoing, but I wondered if you could talk about that more.
Okay, well, even though it's not a major contributing factor, meaning that it's not as significant of a result as when you have very big income distribution changes, but it does, for example, most of what we see in terms of the increase in hybrid adoption, that's related to the gas prices, but more related to the environmental awareness factor than to gas prices. So it does make a case for more education, and especially if you're talking about places like China, where that factor starts out to be rather low compared to developed countries. Yes?
You mentioned one of the variables you included was tax credits for hybrids, for example. I wondered if you looked at, or if this model could be used to look at a balance point between tax credit versus environmental benefit.
Yeah, I mean, I think it definitely can, because from this model we can look at what magnitude of a tax incentive would cause what percentage of hybrid or electric vehicle adoption. So yeah, the trade-off can definitely be somehow calculated into this using this model. So that's a good point. Yes?
I think you touched on it briefly, but I was wondering about why you didn't use the data about how close people lived to transit or had access to it, or land density?
We didn't want to look at that detailed of a data set because we wanted, one of the goals was to be very parsimonious or use very limited data. So if we were to look at individuals and how far they were from transit, we would have to look on a more local scale. I couldn't extrapolate that to the entire population. There's places where there's no transit options at all. There's places that have a lot of transit options. And the distances in terms of how big the metropolitan areas are, or if they're rural versus metropolitan, it makes it very hard to account for on an aggregate scale basis. But you're right, that's one of the things that we do want to look at further down the line. Yes?
Is there any significant split between vehicle choice for urban versus rural areas? Were you able to get that out of your data?
We did not look at that, but we think it's probably going to be a significant factor because most of the data that we looked at mostly looked at passenger vehicles. So that portion of data that has to do with maybe a lot of the sales of trucks, that's more a light commercial light truck data. So we didn't really look at that, but we do think that it is applicable to that. And if we do get more of the data, we can look at that. And especially for places like China, for example, where the rural and urban divide is very big, that could be something very interesting. Okay. Any other questions? Yeah.
Just one. I would think that marketing would have a big impact on auto industry. I'm sure it does have an impact on auto industry decision making. Was that addressed at all, or what's your thoughts on that?
There have been a lot of studies that look at how does marketing or the image of a brand on vehicle choices, and we think that's partially accounted for in the differences of vehicle-specific characteristics, so things like the quality or the perceived reliance of certain vehicles. So we think that's already built into that, the actual car's characteristics. So we didn't actually take into account things like how much advertising spending there was. But yeah, I think it is somewhat accounted for in the model. Yeah.
Yeah, I have another question on this figure.
So this figure shows that when energy price increases, the percent of hybrid car will increase a little bit. But at the same time, the new SUV increased more, right? From about 16 to 19. So how would you explain this? How would it, supposedly when the energy price increase, people prefer, or people tend to buy more hybrid car to save their energy cost. But you know, SUV consumes a lot of energy.
Okay. Yeah. So the difference is between when they do this joint optimization of what car to buy versus and how much to drive. They're going to have different. They're going to optimize at different points of the amount of travel if they were purchasing a hybrid car versus an SUV. So this overall downward trend of total miles traveled, it's an average. So so for the people that are buying hybrids, it could be that their travel remained pretty much constant from the first period and the 10th period, but this overall trend shows an average. So I think that sort of accounts for the difference in what you are mentioning.
Okay, thanks.
Yeah.
Okay, one last question.
With this graph here, we see a 10% increase in energy price for all vehicles. But what about like plug-in electric cars or plug-in hybrids? Those would have a different change in energy cost versus gasoline. So would there be a way of incorporating the byplay between the different energy costs?
Right. You bring up a really good point, which is that in this model, there's not electric vehicles or plug-in electric vehicles. And that's one of the advantages of using this model, which is that we can very easily account for new types of vehicle options or new transportation mode options into this simulation. And And the energy price, so electricity versus gasoline prices, that would be built into the model to look at what are the actual trends of those two energy prices. Yeah. So thank you, everyone, for listening.
Okay, thank you very much, Jenny. Before you all leave here, a couple things. Those of you who are in the class, and I don't know all of you, there's a sign-in sheet over by that desk. So to record your attendance, I got some of you, but not everyone. And if you asked a question, please record it there. And I would also like to put in a pitch for next week's seminar, Beyond the Bike, Linking Bicycles in Transit. And this will be, our speaker will be Colin Marr from TriMet. He's actually an alumnus, a MERP alumnus. So thanks, everyone.